Let's take a look at some power rule problems. This key has already been filled out. I'm just going to walk through the solutions. And so when we start, we're looking for a pattern to occur from here to here. And as we can see, the 2 comes down to give you 2. The x stays, and 2 minus 1 is 1 for the exponent. 4 comes down out front. Take 1 away from the 4 to get 3. The x comes along as the base. So for each of those, that's what's happening. Now, when you have a constant out front, you get the 2 comes down and multiplies by the 3 to get 6. Keep the x. 2 minus 1 is 1, and when you have a 1, you don't have to show the exponent. The next one, 4 comes down. 4 times 5 is 20. X to the 4 minus 1 is 3. When we look at the notation, we do have to be careful that we are talking about a function here with f of x or y, and then when we take the derivative, this first step, we talk about it with a tick mark or hash mark here, and we say f prime of x. Here is y prime. Another way to write it is dy dx, the change in y with respect to the change in x. These last ones are when we're evaluating your derivative at a point. For this, we're evaluating it at x equals -4. So we're going to substitute -4 in for x. We say f prime of -4, y prime of -4. For the dy dx, we have this piece we put down at the bottom. So when you see any of these notation, what it's saying is to substitute in for x in the derivative function. The next ones, these are practice with power rule. Bring the 15 down, so the 2 comes along for the ride. Bring the 15 down to get 15x to the 15 minus 1 is 14. Multiply the 2 into the 15 to get 30, and you get 30x to the 14. For this one, we want to go ahead and rewrite this. Remember, when you move something in a fraction, you change the exponent sign, and so this becomes -3. 7 stays because that was in the numerator. Now we're going to bring the -3 down times the 7 when we take the derivative. So the 7 comes along from the ride, the -3 comes down, x, and then subtract 1 from the exponent. It's -3 already. Take another 1 away and we get -4. So you get -21 and then x to the -4. For problems that look like this is a horizontal line. Y equals a number. That means on the graph it's straight across. All lines that are straight across have 0 slope. Remember, we're looking for a derivative. Derivative is the slope of the tangent line. And if your function is horizontal, the slope everywhere or rate of change is 0. We use that same sort of argument for this kind of problem. So this one has a slope of 0, which is y prime equals 0. For this one, this is a line that has negative slope, so it's coming down like this on a graph. And we know with a linear function that the coefficient of the x is what we get for slope. So for this guy, the coefficient is that -0.5, and so that is going to be our slope. So we get, and I see there's no negative there, we need a negative out front. So this should be a -0.5. because this guy here is negative. Now when we go to the next one, bring the exponent down because we're taking the power rule. You get -9. X to the -9 minus 1 is -10. For this one, bring it out front. 2/3 times x is the same as 2x over 3 because these multiply across. Take the derivative. Again, it's a linear function like this guy, and so you just get that coefficient, which is 2/3. Down at the bottom, we're taking these and combining them together now to say that here's my function. I want to take the derivative and evaluate it at 6, and then I want to know what that means. I take the derivative of this, bring the 2 down. 2 times 5 is 10x. Now I'm going to evaluate it at 6. That's this piece. That means I take this value and substitute it in for x. The x is here, so I'm going to do 10 times 6. 10, 6 is 60. This is the rate of change of f of x at x equals 6, or the slope of the tangent line. For this next problem, it's doing the same thing, It's just different notation. And remember, we're not going to let the notation slow us down. We've got a function. We want to evaluate the derivative at a given x value. And that's what this is asking us then to explain what it is that means. And so we take this function, derivative 2x. Derivative of this piece is -2 because remember it's linear. The coefficient of the x is the derivative. And you do one piece at a time. That's the sum and difference rule. Now we're going to take the derivative and evaluate it at 5. So 2x minus 5 with 2x minus 2 with a 5 substituted in here. We get 2 times 5 minus 2, which is 8. Now what does it represent? Remember the derivative is the dy dx. Evaluated at a given value. It's the slope of the tangent line at x equals 5. And that's the rate of change there, the instantaneous rate of change there. When we do this with a function that is embedded in a word problem, we try not to get too excited about it. It is saying that T is the temperature, that's T is the function, and then that little t is in time in days, so time in days. If they give us how many time in days, we can tell them what the temperature is going to be. You got to look for clues to decide which function you're going to use. Find the rate of change. Rate of change, that's derivative. And so for that guy, we are going to use the, sorry, I used the wrong color, derivative of our function. So we're going to use the derivative of our function, and that's what you see here. We've got t prime. That's big T prime of little t, and take the derivative one term at a time. Bring the 2 down, 2 times -0.1, -0.2. Derivative of 1.2t, coefficient 1.2. Derivative of a constant, remember that's a horizontal line, slope is 0, so we get a 0. So the rate of change of our function is going to be the derivative of our function. Now when we find the temperature, and we're talking temperature now, temperature is that original function. So we're looking for the y value. We're going to take this and substitute it into the original function. Here's the original function. Put 1.5 in for t, So we put it in and square it. Here we multiply it by 1.2, and we get about 100.175 degrees Fahrenheit. Yes, you can round. You should round to be 1 decimal place more than what's in the problem. So that's about 100.18 degrees Fahrenheit. For the next guy, we're looking for the rate of change. Rate of change is the hint that we want to use the derivative. So we substitute 1.5 days in for the derivative. Here's our derivative. So we put the t in, and we get 0.9 degrees Fahrenheit. Now this is a rate of change. So that's saying the temp is rising at 0.9 degrees Fahrenheit each day after 1.5 days. When we take a look at the sum and difference rule in more detail, these notes are from the video. We take this, find the derivative, you bring the -2 down, -2 minus 1 is -3. Yes, you can convert it to a fraction. For this one, you bring the 1/2 down, subtract 1, bring the 1/2 down, subtract 1, you get -1/2, which is really 1/2 x to the 1/2, which is 1/2 root x. And remember, our online homework system may be asking to see it like this. So that's the power rule. The sum and difference rule, just bring that, we're using a power rule, each term, power rule. We know to do that when we see a variable raised to some number exponent. And so bring the 5 down, take 1 away from the exponent to get a 4. Bring the 11 down, multiply it by that -2 to get -22. X to the 11 minus 1 is 10. X to the 7th, bring the 7 down, subtract 1 to get a 6. Bring the 7 down, subtract 1 to get a 6. Bring the 4 down, 4 times 3 is 12. X to the 4 minus 1, 3. Now remember, don't let notation get in your way. This still is saying take the derivative of this guy. So x cubed, bring the 3 down, 3x squared. X squared, bring the 2 down, 2x. x to the 6th, bring the 6 down, take 1 away from the exponent, 6x to the 5th, bring the 2 down, 2 times 5 is 10, x to the 1, which is, we write without that 1. Now sometimes we have to simplify before we take a derivative, because you can't, with us and our rules, we don't do the easiest rule possible. And the easiest rule possible is the power rule, and sum and difference is just power, power, power. And so this guy we can multiply in. X is to the first power times this, which is x to the 1/2. Add the exponents, you get 1/2, but we don't write 1/2 here. We write it in proper fraction, 3/2. Then we take x times 3, which is 3x. This guy, we just rewrite this as x to the 1/2, so we're done. This, we changed it to exponential, so it's sitting here as opposed to in the denominator. So we go ahead and simplify each first. Now we take the derivative using the power rule, one term at a time. Bring the 3/2 down, take 1 away from 3/2, so this is 3/2 minus 1, which is 2/2, so you get 1/2. Derivative of 3x is just the coefficient because it's linear, so you get 3. Next guy, 6 comes along for the ride. 1/2 comes down, x to the 1/2 minus 1, negative 1/2. Now we multiply in, don't leave them like this with a number hanging out front. 6 times 1/2 is 3, x to the negative 1/2. This one, negative 2 comes down, multiply by the 3, negative 6. Negative 2 minus 1 is going to give you negative 3. When we take a look at the top of the next page, you are going to get, again, some conversions first before you take the derivative. When you're given a number of them, I would do all the rewriting first, then change to derivative mode and change into derivatives. Square root of x is x to the 1/2, so we just rewrite that. Now this one we're multiplying in. X times 2x to the 3rd gives you 2x to the 3 plus 1 is 4. X times minus 3x gives us minus 3. 1 plus 1 is 2. Remember, when you have like bases, you add the exponents together. For this one, we're converting to a negative exponent so we can use our power rule. And we move it into the numerator, which changes the sign from positive to negative, so negative 4. Now we use the power rule. Bring the 1/2 down. 3 times 1/2, 3/2. X to the 1/2 minus 1. 1/2 minus 1 is 1/2 minus 2/2, which is 1/2 with a negative in front. For these, bring the 4 down times the 2 is 8. X to the, subtract 1 from the 4, 3, 8x cubed. Bring the 2 down. 2 times negative 3 is negative 6. X to the 2 minus 1 is 1. Remember, we don't write that 1 there. 2x to the negative 4. Bring the negative 4 down to get negative 8. X to the negative 4 minus 1 is negative 5. So that's it. Hope you're having a great day.